In 1936, two physicists at Caltech detected an elementary particle, the muon, from showers of cosmic ray particles. However, something doesn't add up here. The half-life of muons is 1.5 microseconds, which means it can only travel around 700 meters before decaying, far too little to make its way to the particle detectors. So how did they detect it? Well, let me explain something first. If you say that this person is moving 11 meters per second relative to the ground, you'd be wrong. Why? Because the faster you're moving, the slower you move through time, and we can prove this with two hints. 1. The principle of relativity, and 2. The speed of light is constant for all observers. Imagine you're on a train shining across a flashlight. Because of the first postulate, you see the light travel in a straight line to the other side. However, your friend on the ground sees the light travel diagonally, and thus a farther distance. Using the Pythagorean theorem, we can find the length of the light traveled viewed by your friend. After doing some simple algebra, we can rearrange for the ratio t prime over t and arrive at this equation, the Lorentz factor, which is the ratio of time passed for the stationary observer to the moving observer. So what does this mean? Well, if you plug in any number v between 0 and 1 exclusive, you will find that the ratio is always greater than 1, meaning more time actually passed for the stationary observer than the moving one. Plugging in the speed of the muon, it actually survives for about 19 microseconds for us here on Earth, enough to travel to the particle detectors.